Right, so solve for the following. So this one here is you need to use your formula sheet, eh? Get stuck, use your formula sheet. On the formula sheet, what does it say? Y equals b to the power of x, and it goes to log of b to the y equals x. Is that right? On the formula sheet? So if you're looking at this one here, the 3 is the b here, so it's going to be there. The 4 is the x here, so it's going to go there. And the n must be your y. So 3 to the power of 4 equals n. So n is just 81. Happy with that? Next one, same thing. N is your b there, so that's n to the power of 2 equals 81. Any questions on that one? How do you solve an n squared? Square root. When you take the square root of something, what do you have? Charlie, what do you have? Plus and minus the square root of 81, which gives you positive negative 9. Okay? You happy with that? Problem is, can you guys take the log of a negative number? Now, if you remember back to our graphs, the graphs we had, for logs looked like that. And there was no logs of negative numbers. So what does that mean? Yeah. Can't be negative 9, therefore n is your 9. Okay? Now, probably some of you just gave me 9s to start with, but you needed to tell me that it could be 9 or negative 9 and get rid of that. Next question. That one harder? Yep. This is actually a level 1 MCAT question. Okay? These sort of questions are coming more and more into MCAT. So with this one, you've got x's in the exponents. So you're going to have to take logs of both sides. But in reality, you should know that 27 is 3 to the power of 3. So that one there is actually 3 to the power of 3, lots of x squared, and that equals 3 to the power of px minus 3. Does that make sense? So that's actually 3 to the power of 3x squared, and that equals 3 to the power of px minus 3. Any questions with that? Now, because it's the same base, we don't have to take logs. We can just say 3x squared must be px minus 3. Happy with that? So now we can set ourselves up a little quadratic formula. Okay, we can set ourselves up that part there. Okay, but it says which values of p does the equation have no solutions? What does that remind you of? Something about having no solutions. Yeah, what's less than 0? Not the quadratic formula, but the discriminant in the quadratic formula. Does that make sense? So no solutions implies that the discriminant, which is b squared minus 4ac, is less than 0. Happy with that? Those parabolas that didn't touch the x-axis because the square root is a negative. So what this says is that negative p squared minus 4 lots of 3 lots of 3 has to be less than 0. Happy with that? So that's just p squared is less than, I think that's 36? Okay. So that's P minus 36 is less than 0. Any questions with that? And that there's a graph, eh? P squared minus 36 is a graph. And that graph just looks like that, eh? So where is that graph less than 0? Well, what we do is we solve, yeah, just below the x-axis. So what we do is we solve where that there equals 0, which should be P minus 6 and P plus 6 equals 0. So therefore P is negative 6 and positive 6. Yeah? So where this graph touches, there is negative 6 and 6. So where is that graph less than 0? In between those 2 points. So you're saying P is less than negative 6. Sorry. P is greater than negative 6, but less than 6. Okay? Any questions with that stuff? Those are the first part. So there's your marking schedule. You gave me N is 81 for the first one. You got yourself an achieved tick. N is 9. Achieved tick only. N is 9 with the negative 9 ruled out. There's your merit tick. And between negative 6 and 6 gives you your excellence tick. If you set up this part just here, there's your merit tick. And if you can give me that part there, there is your achieved tick. Happy with that? So Henry buying his Prius, which is a good car by the way, 18,500 each year, expected to continually depreciate by 16% of the previous year's value. So if you were to plot this on a graph, what it would look like is it would start off at 18,500, and then the next year, the next year, the next year, it's going to start to each year get less of a value, if that makes sense, less of an amount. Okay? To me, I know what that graph is. That's an exponential graph. I'm happy with that being an exponential graph. Okay? If you can't, then hopefully that graph there showed you why. And if you think back to our graphing topic, the equation for an exponential graph is y equals a o something along those lines. So a o times r to the power of n, or might be n minus 1 or something along those lines. So there's a general formula for it. Happy with that? What does the r represent? That there's the ratio at which it is going down. What does n represent? The years. What does the AO represent? Yeah, the original cost. And that's the original cost. Okay? Because if I asked you to calculate how much it would be after year 1, hopefully you will all go, that is 18,500 times what? 0.84. Okay? You could find 16%, which is 0.16, and then minus that off 100%. But 100% minus 16% is 84%, or 0.84. Does that make sense? So if that's the original value and we times it by 0.84 to the power of n, does that give us what it would be each year? When n is 0, that part there is 1. Good, because anything to the power of 0 is right? If that gives you original value. If n is 2, then it'll be 18500 times 0.84 times 0.84. Hopefully that makes sense.
Yeah.
So what you're trying to do now is solve where that there, the power of n, is less than 10,000. Happy with that? So what does that now look like? It's a log question, eh? Because you've got an n as your unknown up there, which is a explain. So to solve that one, what are we going to do? Divide both sides by the 18,500. Happy with that? So that's now just a complicated version of the very first question today. 10,000 over 18,500, that's just a number. That number is close to 0.5405. 10,000 divided by 18,500 is close to 0.5405. And the calculator should be roughly what it is. Might even be exactly, I don't know. And then using that log formula, you're going to get n is equal to the log of whatever that number there is, with a base of 0.84. Sorry, I haven't written that very well. With a base of 0.84. Okay. To do that on your calculator, how do you do that? On your calculator, you do that by going log 10,000 over 18,500 divided by the log of 0.84. Okay. You get an answer of 3.53 years. Therefore, n has to be more than 5.2 what? 5.28. So that would be around 5.153, wouldn't it? Happy with that? We'll probably n is greater than 3.53 or n is greater than 4. Those are both accepted.
So you say any equals 4 on the other.
Yep, you can do that. Yep, they're going to accept both of those answers.
Oh, okay.
Generally, they'll accept it. On this particular occasion, when you talk about a pressure, because it continually will decrease, halfway through the year, it will be an amount that is between the third year and the fourth year, if that makes sense. Okay. So that's why greater than 3.5 years is probably okay. Example. Any questions with that one? Now, if you remember back, some of you won't. To go from there to there, what we did is we took the log of both sides, and there's a log rule that you can do. So we turn it into that there. Okay, and then we divide by that log of 0.84, which is that step just there. Okay, if you lost that part, but that's the maths that we did on the log vessels. So this part is combining the previous question with this one. So a Camry, same time as Henry bought the Prius, the Camry depreciates 19% as opposed to 16%. So the Camry is 2,600 times by the 0.81. to the power of n. Happy with that? Henry's Prius, which is 18,500 times by 0.84 to the power of n. You're trying to find where both of those are exactly the same price. Happy with that? You're trying to solve where that equals that. Happy? Now, this one's quite a tricky one, but what we're going to do is we're going to move all the n's to one side and the numbers to the other. So we're going to divide this by 18,500. Divide this by 18,500. Happy with that? We're also going to divide it by the 0.81 to the power of n. Happy with that statement just here? So that turns into a statement that is 2,600 divided by 18,500, and that equals 0.84 to the power of n and 0.81 to the power of n. Okay? Because they're both to the power of n, what you can say is that is actually the same as that over that to the power of n. Okay? Which, if you think about it, is again an easy version, sorry, a much harder version of the very first one. So you're going to say n is now the log of 2,600 divided by 18,500 all over the log of 0.84 over 0.81. Okay? Put in the calculator, press equals, gives you an answer of 5.504 years. Okay? Happy with that? Now the key thing, that there looks tricky, eh? But the key thing is, this here, that there is just a number, eh? If you go 2,600 divided by 18,500, that gives you a number. That number is 0.81858. No, that's not right.
That's 1.22.
1.22. So the answer schedule went the other way. They did. But it's all right. We did it the same way. We did the same method, different way. So that's just number 1.22. The 0.84 divided by the 0.81. Again, that's just a number. I don't know what that is. 1.04. Okay, so that there is just a number 1.04. And so this here is just n equals the log of 1.22 over the log 1.04. Okay, if you do that calculation, it's going to be roughly 5.5. Okay, so I've just kept those numbers unrounded, if you like. Happy with that? And there's your marking schedule for the stuff. So, setting up that equation got you an achieve tick, or correct answer only gave you an achieve tick. Otherwise, going through that process and getting that answer is your merit tick. Okay, so hopefully setting up that equation we can do now you've thought about it. Okay, that probably should be less than 110,000, isn't it? Was the question less than 10,000 or was it equal to 10,000? And this one here, again, if you set up that equation, there's your achieve tick. Isolating n, so doing that process there, that's your tricky part. There's your merit tick. Okay, and getting that answer and saying it is 5.5 years. And actually using it to answer the problem. Questions with that? The 0. That's what I was trying to say. They've done 18,500 divided by that. So that's where I was saying is 0.81. They did it the other way. Any problems with that? Yep.
But when you divide it by 22,600, you only like divided the 18,500 by that and not the 0.84 to the power of n. Because don't you have to do the same thing to?
But remember that's like an equation like 4x divided by 4 becomes x, doesn't it?
Oh,
It's
yeah,
the same process because it's a times. Yep.
Yeah.
Dividing that once. Yep. Okay, so these ones, remember, this is, I think, generally the exam has an exponent type question. So what is a negative exponent? What does that actually mean? Okay, so you guys, this here is going to be 3 to the negative 4, x to the negative 4. That's what that's going to be. Okay. Now, if you in your calculators go 2 divided by 3 to the power of 4, that'll give you the coefficient. Okay, but then ultimately that's just 2 lots of 3 to the power of 4, x to the power of 4, which is 81 times 262. Happy with 162 x to the power of 4? Yeah. So that negative there means it goes to the other, it goes from the denominator to the numerator. Okay? Or if it was a numerator, it would go to the denominator. Okay. Next one. This part here simplifies in my mind, doesn't it? That's x to the power of 4 over 4. Remember that? Yeah. And this is all raised to the power of 5 over 2. Okay. Now, raising that to the power of 5 over 2, well, that's just going to be x to the power of 4 times 5 over 2. And this is going to be 4 to the power of 5 over 2. Okay. Now, on your calculator, again, if you press 4 to the power of 5 over 2, it'll give you a number. So you can just put that number there. But ultimately, that over 2 means you're taking the square root of a number. Square root of 4 is 2. Yeah. 2 to the power of 5 is 32. 2 to the power of 5 is 32. Good, thanks, Ross.
You're welcome.
X to the power of 4, if you go 4 times 5 and 2, and that's just 10. So your answer should be x to the power of 10 over 32. Happy with that?
I'm not happy with it, but
Okay. Next one over there. Same process. You're going 16 x to the power of 8. Because it's a negative, we can put it to the bottom line of a fraction and have that as a positive. The same thing we did over here. We move this negative to the top line, from the denominator to the numerator. We're taking that from the numerator to the denominator. Okay, and again, 2 parts of this. If you just go in your calculator 4 over 16 to the power of 7 over 4, that'll give you a number on your calculator. Some people will do that right now while I'm talking, I hope. But ultimately, sorry, excuse me. You've also got to multiply this by x to the power of 8 times 7 over 4. Okay? So on your calculator, 7 over 16 to the power of 7 over 4 gives you 1 over 32. 8 times 7 over 4 gives you 14. So that answer there is 1 over 32 x to the power of 14. Okay, I get that they're actually not as easy as they look, but there are some processes that you should know and do know from last year. When you're raising something to the power outside the bracket, you multiply the exponents. Okay, hopefully you remember that. From this year, anything that is negative, the exponent goes from the denominator up to the numerator, or vice versa. It's a denominator, it goes to the numerator. It's the numerator, it'll go to the denominator. Any questions with that one? Alright. Let me close that door before someone ruins it, please. Next question, simplify this. How do you simplify those sort of questions? You've got to factorize it, eh? Top line has a common factor of 3, so take that 3 out. Turns into 2x squared minus 7x plus 3. Bottom line has a common factor of 4. Take that 4 out, and you've got that there. Any questions with that step to start with? That top line is now a 2x squared. So we did that. If you remember, we went 2 times 3 is 6. What are now the factors of 6 that add to negative 7? Factors of 6 that add to negative 7? Negative 6 and negative 1, yep. So that 2x squared comes from that part of my box method. That 3 comes from there. My negative 6x and my negative x, they're going to add to my negative 7x. Eh? And if I look along here, common factor is 2x in particular. Eh? 2x times x gives you 2x squared. 2x times negative 3 gives you negative 6x. X times negative 1 gives you negative x. Negative 1 times negative 3 gives you positive 3. Who remembers doing that one? Yeah? And that bottom line, that's the difference of 2 squares, eh? X plus 3x minus 3.
Yeah.
So this here simplifies or factorising further to be 2x minus 1, x minus 3, all over 4 lots of x plus 3, x minus 3. Okay? Happy with that?
Yeah.
So what's my answer? That and that, they're going to cancel out. Okay, the 3/4 doesn't have a common factor, so it's just going to be left as 3/4. That just gives you an answer of 3 lots of 2x minus 1 over 4 lots of x plus 3. That's your rational expression. They're quite a common question as well. Looking at the marking schedule, you can see correct answer. So there's your achieved tick. We'll get in there. Correct power or correct denominator. So you just need one of that or that for an achieved. Get both, you get your merit tick. This or negative. We won't have to necessarily worry about that at this stage. We'll talk about that at a later stage. This one here, again, correct power of x or correct coefficient. So if you get the x to the power of 14 or the 1 over 32, there's your achieved tick. You get both, you get your merit tick. So just one of each of the achieved tick. And the last one, if you can factorize any of those two properly, you would have got an achieved. Otherwise, get to there and that one, so therefore that one there, here is your merit. That makes sense, is it? So that's one of those gets you a U tick. Questions, problems with that one? Okay, so as you sort of said, having some sort of picture might be helpful here. Is that fair? So if we draw some sort of picture, here's a right angle triangle. I love the right angle triangle, don't anyone say anything different. That has 3 times the length of its base. So this is the hypotenuse, that's the base. So hypotenuse is 3 lots of x, is that right? Everyone happy with that statement? So this one over here must be, what's that one there? What is that measurement?
We don't know what it is.
But if the perimeter is 50, will we know that's 50 minus? Does that sound about right?
Yeah.
So that's 50 minus 4x because the perimeter is 50. Any questions with that so far? Right. So now how are we going to find the area? How would you find the area?
X times 4x over 2.
So we're going to go area equals x times 50 minus 4x all over 2. Is that right? You happy with that? It's not what the answers are going to say here, but because we are trying to find a length there. So what is x? We need to find what x is. So how are we going to find what x is?
Yeah, you're going to be fucking.
Pythagoras theorem?
Yeah.
Okay. So from here, this 3x squared is going to be equal to x squared plus 50 minus 4x. Is that what you guys are saying? So if we expand all of that, we're going to get x squared plus that minus 400x plus 16x squared. And this is equal to 9x squared. Looks pretty tricky, eh?
Yeah, I didn't know that way.
If we collected all that part, we're going to left with x. 0 equals 17 minus the 9 is 8x squared minus 400x plus 2,500. You solve that using your quadratic formula. I'm pretty sure they might even factorize. No, they won't factorize, but you can solve it via quadratic formula. You'll get an x of a certain number, and then you substitute that up here, and you'll get your answer of
7.32.
well, x is 7.322. Yeah. Or another one, which will be a negative answer. And then substitute it up into here. So it's going to be 7.322 lots of 50 minus 4 lots of 7.322 all divided by 2, which gives you an answer of 75.82. Happy with that? Okay, Charlie's going to check that quadratic formula does solve to that value in another one. Yeah, so as Charlie said, so that's one answer. The other answer is, what was it, 42? Okay, but if it's 42.68, then that length there is a negative length, which won't make sense. And if that's 42.68, then that's going to be 120, and those perimeters aren't going to add up to 50. Okay, so although it's positive, it doesn't meet the criteria. Happy with that? The next one, this one's quite a tricky looking question, eh? Okay, and this is a common style of question. If I said to you, let x equal 3 to the power of n, then this middle part would be minus 10x, wouldn't it?
Yeah.
And that would be plus 9, and that would equal 0. Happy with that? What would 9m be? No. 9m. What would 9m be? That would be 3 squared m. You can manage that. Which would actually be 3 times 2m, which would actually be 3 lots of m squared. If you can follow all that expanding and out of brackets, etc. So that's x squared, isn't it? Because 3m is x, so that's x squared. So that particular problem is just solving x squared minus 10x plus 9, which to be fair is a straightforward quadratic. If I gave you that one, it would be a straightforward quadratic that you can factorize. X minus 9, x minus 1 equals 0. Happy with that? And so from there you've got x equals 9 or x equals 1. Have we solved for m? So what we say is, well, 3 to the power of m therefore is 9. So m must be, because 3 squared is, therefore m equals 2, because 3 squared is 2. You can solve that using your logs if you needed. Okay. Or 3 to the power of m is 1, so m must be 0, because 3 to the power of 0 is 1. So there are your 2 questions on that. Does that one there look hard now? So what was the key thing? Yeah, this part here. That part there is the key thing, and actually then, therefore, that part there, which if you can see that, then hopefully it makes a bit more sense. Questions about? So here's the answer schedule for that question. Obviously, I went way different, if you can make sense of that. They've said, rather than it h being 50 minus 4x, they've just said h, and said, well, h is just root of x, so root 8 of x, and substitute in that to give your answers. Still that Pythagoras' theorem there, being the 2 sides added to the long side squared. Any questions with that one when you look at it? So the achieved is if you can get some sort of equation for h. In my one, when I didn't perform that h, you would have got that for probably setting up that quadratic equation. Equation for perimeter given with x's only. There's your merit there, and there's your excellence. Okay, for my one, giving that x value of 7.2 would have probably been the merit tick, because there you did a alternate methods. And for the next one, yeah, that step there looks like that's your achieved tick. Getting down to there is your merit tick, and actually answering your question would be your excellence tick. Okay, happy with that? Okay, so writing as a single fraction in its simplest form, how do you do that? Yeah, denominators have to be the same. So what's the common denominator here? The lowest common denominator will be p plus 3 times 2 lots of p minus 2. Actually, might be a little bit different than that, but we'll go with that to start with. Yeah. So 2 lots of 2p minus 2 all over p plus 3, 2p minus 2. Happy with that? Timesing by 1 in the form of 2p over 2, sorry, 2p minus 2 over 2p minus 2.
Yeah.
This is the same, times by 1 in the form of p plus 3 over p plus 3. Okay. Now the denominators are the same, what can we do? Make it one big fraction, so that's going to be 2p. It's going to be that, sorry. Quite say that, that's what I was meaning. Happy with that? Now what we're going to do? Expand those out. That's 4p minus 4. So it's going to be 4p minus 4 minus 5p squared minus 15p all over p plus 3, 2p minus 2. Happy with that? You notice that 2p minus 2 is actually got a common factor in itself?
So,
Yeah. So we probably shouldn't take that out the front at some stage. We couldn't take it out front at some stage anyway. From there, I can just collect my like terms, eh? So that goes to negative 5p squared minus 11p minus 4 all over p plus 3, 2p minus 2. Questions with that?
He went
Could you go further? How could you go further than that?
with the bottom.
Spin the denominator? Could do. That there is actually the answer that you could give. But yep, you could give, what's that? 2p squared minus 4p plus 6, that's going to be plus 2p, isn't it? Minus 6. You're right? Minus 2 plus... No, minus 2 plus 6 is plus 4.
yeah.
Alright. So 4. Yep, so you could do that. Could you go any further than that? How do you go further than that?
No,
You
you can't.
can't.
That's right.
If you factorise the top line and factorise the bottom line, you're going to get back to the brackets. So that there will not have a factor of p plus 3 or 2p. And you cannot, make sure you do not try and simplify the p's. You know what I mean by that, eh? Pardon me? Because there's pluses and minuses in that fraction. You know, if you think about the fraction 3 plus 4 over 4, you can't, that's 7 over 4, isn't it? You can't cancel those 4s out and make it 3 over 1, can you? But a lot of people do that. Okay? Looking at the marking schedule there, if you combine to make one fraction only, so there's your achieve tick. Getting down to one of these two answers is your merit tick. Seems achievable, eh? Yep. Next one. There's a few different ways of approaching this one here. My way of approaching it would be to say that there comes from an equation that looks like that. If it's got roots of 3 over 5 and negative 2 over 5, then that has an equation which is 5x minus 3 and 5x plus 2. Happy with that? Now, that equation there has those roots, doesn't it? And so now if I expand this, 25x squared plus 10x minus 15x minus 6 equals 0. Well, that's pretty much pretty much the same as that above, isn't it? Except this part here is negative 5x. So that there must be negative 5. Yep. Other ways that I've seen substitution.
Yeah. So 25 in brackets 3 over 5 squared plus h in brackets 3 over 5 is equal to 6. And then I just chucked the first part into my calculator, which gave me 9. And then the second part has to equal 3 to get to 6.
So you're substituting that value.
I substituted one of the roots for x.
What's that part there?
9.
Is that 9?
Yeah, it is 9. Wouldn't do calculator. And I got 8.
That?
Alright, so I got the 9 and then plus h3 whatever.
Yep.
And then you end up with h in brackets 3 over 5 has to equal negative 3, and then you divide by
3/5, yeah.
3/5. And
Yep.
then that's how.
Cool. That's another way of doing it.
Would that be acceptable?
We'll have a look at the marking schedule in a minute. The other way of doing it is when you factorise that question there. If you were to factorise that question there, how do you do that? What are you doing?
Finding the factors.
Yeah, you're finding two numbers that multiply to that add to that, eh? And so here, what you're saying is the two roots will multiply to that and add to that. So these two roots add to that there. Okay? So in other words, x squared plus h over 25 x minus 6 over 25, the 3/5 and the negative 2/5 is equal to h 25. That's the marking schedule, the way they do it. Yeah. The value of q. Two real solutions. What does that suggest to you?
It's bigger than 0.
Yeah. Two real solutions sort of automatically say to you, I'm asked the discriminant. Two real solutions suggests that it's greater than 0. You guys happy with that? So that equation you need to write in that ax squared plus bx plus c equals 0 way. Happy with that? So therefore we've got right. So remember we said discriminant. So we're looking at that part there being greater than 0. We've got that 3x squared minus qx plus 3q equaling 0. So there's our A, there's our B, and there's our C. You guys happy with that? So now what we need to do now is go B squared. That's minus Q squared minus 4 lots of A, which is 3. Lots of C, which is 3Q. Happy with that? That there has to be greater than 0. That's now going to be Q squared minus 36Q has to be greater than 0. Happy with that? Now that's a graph, eh?
Yeah.
That there's a graph, and that, well, sorry, that part there is a graph. And that graph has intercepts of 0 and 36. Right? And so there's your graph like that. So solving these quadratic inequalities, you've got my suggestion to you was to think back what the graph looks like. So to find that root there and that root there, 36 to 0, what you end up solving is where does q squared minus 36q equal 0. Right? Yep. Solve that one by factorising it. So it's q lots of q minus 36 equals 0. So 0 and 36. Whereas this graph here greater than 0? Above the line. So it's greater than 0 there and then. So the answer will be where q is less than 0 and where q is greater than 36. Happy with that statement?
Yeah.
Didn't really try it. Well, that's a disappointing thing. Okay, so this maths block is 60 by 40. So that's 60 and that's 40. Happy with that? So this area is 2,400. Happy with that? Now you just have to figure out the graphs. Next, a way of giving me the area of the graphs. Okay, and so how are you going to do that? You say this part here, if we call that x, that's the width of the path. That's what you're trying to find, eh? Width of the grass around. So let's say x equals the width of the grass around. Happy? Since it's the same everywhere, that's x there, that's x there, that's x there, that's x there. Happy with that? So can you find that expression now for the shaded area? Sure you could. I'm going to pause it. I'm going to break it down into little parts here.
Then you got 40 plus 2.
Happy with that? If I break it down to those parts then. So that area there is an x squared, eh? And there are 1 of those, 2 of those, 3 of those, 4 of those. Happy? That area there is 40x, isn't it? And there's 2 of those. Happy? That area there is 60x, isn't it?
Yeah.
There's just 1 of those. What's this area here? What do those 2 areas add up to? Yeah, why is it 40x? Because that part there is a third of the 60, which is obviously 20. So you subtract 20 off the 60 and you get 40x being those 2 parts there. Happy with that? So what you've got now is an expression of 4x squared plus 40, 40, 40 plus a 60, 180x. And what does that equal?
2400.
Yeah, because it's the same area as the block itself. So that there equals 2,400. Okay. Solving a quadratic, we should all be able to do that now because the systems of equations make it equal 0. And how would you go about solving that one? Yeah, heaps of different ways. The easiest way would just be quadratic formula. I mean, you can, those numbers there look like they're multiple. Common factor of 4. Okay, but chuck in the quadratic formula.
Because I took it as a third of 60, but what if someone interpreted it as a third of 60 plus 2x?
That would be wrong.
Right. So even though that's
Yeah,
That seems like that should be a fair.
yeah. I fair assumption, especially if you look at that picture, eh? Because it is actually looks like it's a third of the whole thing, yeah. But in the words, which takes up a third of the 60 side. So that's how I've interpreted that to be a third of the 60 as opposed to a third of the 60 plus the 2x. Yeah, it's a good question though. But to be fair, if you'd done it that way, I probably wouldn't have been punished. But anyway, from here, quadratic formula, x squared, or x equals negative 180 plus and minus the square root of 180 squared minus 4 lots of negative 2400 all over 2 lots of 4. Put in the calculator. The plus answer will be 10.76. The negative answer will be negative 55.76. And so what do we say? Yeah, because but x cannot be equal to negative 55.76. Therefore, x is 10.76. And that is the width of the grass around. Okay. Happy with that? So marking schedule for those last 3. You see that's the way that they did it with that sum of roots in there. Okay. Anyway, you get to that h equals negative 5. There's your r tick. And some relevant way of getting to forming an equation will be your achieve tick. This thing here, this I think should be equal to 0. And this will have 2 real solutions if the discriminant is positive. Okay, because that's what the question was asking, eh? Yeah. So I'm not sure why I put that there. So the discriminant's positive. Got 2 solutions there. So there's your excellence tick. Excellence tick being both of those, merit tick being one of those, and getting to the discriminant part here is your achieve tick. Questions with that? Excellence for the next one. Down at the bottom, your merit tick looks like is to solve that particular problem. Okay. And there is your achieve tick there. If you had done a minor error with setting up the equation and still solved it consistently, I think you probably could have still got a merit there. Maybe even an excellence based on those words. Okay. Questions, problems with that?